Section 5.3, Day 1, Solving Trigonometric Equations. We're going to learn how to solve trig equations, what it looks like on the graph, and how many solutions we should be getting. The first thing is, though, is theta equal pi over 3 a solution to this equation. So instead of just solving the equation to figure that out, what we're going to do is just going to plug in the information that we know and see if it is true. So 2 sine of theta, theta is pi over 3, and we just want to see if this is equivalent to 0. So 2 times sine of pi over 3 has the ordered pair 1/2 square root of 3 over 2. So sine would be square root of 3 over 2. Looks like the 2's will cancel. We'll get square root of 3 minus 1 is equal to 0. Well, obviously that is not true. So theta is equal to pi over 3 is not a solution. So the next one is pi over 6. Is pi over 6 a solution? So we'll do the same thing. 2 sine of pi over 6 minus 1 equals 0. So 2 of pi over 6, that would be the ordered pair square root of 3 over 2 1/2. So that would be 1/2. 2 times 1/2 is 1. 1 minus 1 is 0. So is pi over 6 the only solution to this equation? And so what I've done on the graphing calculator is I've graphed the equation 2 sine theta minus 1 is equal to 0. Remember that this equals 0 right here represents your y value. So what are we looking for? We're looking for where the graph crosses the x-axis. What is x when y is 0? Well, you can see that we have a lot of different values that cross the x-axis. So is pi over 6 the only solution? No, we got a lot of solutions here. All these points where the graph crosses the x-axis, those are going to be our solutions. So we have multiple solutions here of this equation. So how are we going to identify all these solutions that do occur? Well, let's take a look at this example. We kind of shortened it up a little bit here. So sine of theta equals 1/2. So if I'm just looking for the solutions from 0 all the way around to 2 pi. Those are the only solutions I want. What are those solutions? Well, where is that ordered pair for sine of theta? Since sine is your y value, we know the x is square root of 3 over 2 and the y is 1/2. What is that ordered pair? Well, that's going to be our pi over 6. And there's multiple places where that occurs on the unit circle. Well, the first one is we know that pi over 6 is 1. That gives us, remember, the ordered pair square root of 3 over 2, 1/2 on the unit circle. So sine of theta is equal to 1/2 when theta is equal to pi over 6. Where else does it occur? Well, sine is positive, since you're talking about the y value. Sine is positive in quadrant 1, but also in quadrant 2. So what's the angle that gives us that reference angle of pi over 6? Well, this angle would represent 5 pi over 6. And so sine of 5 pi over 6 would also give us the value of 1/2. Now, if we tried to go in quadrant 3, sine is negative. In quadrant 4, sine is also negative. So only the angles pi over 6 and 5 pi over 6 are solutions to this equations in between the intervals 0 to 2 pi. Now let's take a look at the graph. So since sine is periodic, there are an infinite number of solutions. So I've graphed sine of theta, that's the sine curve, and then I graphed the horizontal line y equals 1/2. And so what we're looking for is where the graphs intersect. So once again, you can see that there are multiple places where the graph is intersecting. So with sine being periodic, we have this general form for all the solutions that would occur. Theta is equal to pi over 6 plus 2n pi, where n is any integer. So you can also do -1, -2, as well as the positives. So why are we adding 2n pi or 2 pi as well multiple times? Well, remember, sine has a period of 2 pi. So since sine has a period of 2 pi, we should be able to add 2 pi and keep rotating around this unit circle. So once again, for example, if this is pi over 6, I should be able to add 2 pi to get back to that same location to still equal 1/2. So the end just represents that multiplier of 2 pi. We can also do this with 5 pi over 6. So theta is equal to 5 pi over 6 plus 2n pi. So that's the general formula for the solutions if we want to list out all the possible solutions. If we just want the solutions for the first rotation between 0 and 2 pi, it's just pi over 6 and 5 pi over 6. All right, let's take a look at another pretty simple equation. Tangent of theta is equal to square roots of 3. What ordered pair gives us square root of 3 when we take sine divided by cosine? That would be when we have x as 1/2 and y is the square root of 3 over 2. So if you take square root of 3 over 2 divided by 1/2 or multiply by its reciprocal, you'll get square root of 3. So what angle is this? Well, this would be pi over 3. So we want that as our solutions. So pi over 3, that would be one solution. Remember, it's positive, positive in quadrant 1. Quadrant 2 is negative, positive. So that angle would give us a negative. We don't want that one. Quadrant 3 is negative, negative. So that would also mean tangent is positive. So what is the angle in quadrant 3? So we got pi over 3, 2 pi over 3, and then in quadrant 3 would be 4 pi over 3. And then in quadrant 4, once again, this would be positive, negative, so the tangent would be negative in that quadrant. So only in quadrants 1 and 3 is tangent positive. So the two angles that would represent the solutions would be the angle pi over 3, and also theta could also equal 4 pi over 3. The period of the tangent function is pi, so it only takes pi units to repeat. So therefore the general formula for the solutions for tangent would be theta equals pi over 3 plus n pi. Okay, we could create two equations like we did for sine or cosine, but with tangent, because its period is pi, you won't have to find that one angle and then add n pi, once again, where n is an integer. So think about this. If I wanted to take pi over 3 and add pi, that would be pi over 3, find a common denominator, 3 pi over 3, which gives us the angle in quadrant 3 as 4 pi over 3. Once again, looking at the graph, where do the graphs intersect each other? They're going to intersect in multiple places. But since tangent has a period of pi, we can just add the general form pi to that first angle that we find. Alright, let's take a look at a couple of equations here that we can solve. Solve 2 sine theta plus square root of 2 equals 0 over the interval 0 to 2 pi. So we're not using the general formula. We're not going to find all the solutions. We're only going to find the ones between 0 and 2 pi. So we want to isolate the sine of theta. So we will do that by subtracting the square root of 2 to both sides. So that'll leave us with 2 sine theta equals negative square root of 2. Divide by 2. So sine theta is equal to negative square root of 2 over 2. So what angle gives us square root of 2 over 2? Well, we know our pi over 4 is square root of 2 over 2 for x and y. And we want negative. So where's sine negative? Well, sine is your y value. So it'll be negative in quadrant 3 and negative in quadrant 4. So what angle would that be for theta? Well, we know it's a 45 or a pi over 4. So we want the ones in quadrants 3 and 4. So that would be theta is equal to pi over 4 would be in quadrant 1. 3 pi over 4 is in quadrant 2. So we have 5 pi over 4, and then 7 pi over 4 would be in quadrant 4. So theta is equal to 5 pi over 4 and 7 pi over 4. And just like any equation, you could plug these back in and check to see that they do work. Let's go ahead and look at example 5. Solve 4 sine squared theta minus 3 is equal to 0. So once again, we want to isolate the sine value. So we will add 3 to both sides and then divide by 4. So we'll get 4 sine squared of theta equals 3, then divided by 4. And this is sine squared of theta equals 3/4. Since it is squared, we can take the square root of both sides. And sine theta would be equal to plus or minus the square root of 3 over the square root of 4, which simplifies to 2. So now we know sine of theta is equal to the ratio of square root of 3 over 2. That would be the ordered pair 1/2 square root of 3 over 2, which would be the measure pi over 3. Realize that our interval is from 0 to 2 pi. This is in radians. So when we go to answer these questions, they need to be in radians. Now, since we do have the plus or minus, that means it's going to cover all the angles in each of the 4 quadrants. So we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So all 4 of them are part of our solution. So once again, theta is equal to all 4 of these angles. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3 would be the solution. Don't forget to include your summary. What were those important takeaways from this section?
My name is Evelyn Bess. I'm going to draw an animal. Could you guess this animal? I need green. Do you know their mouth is under it? That's the sand. Thank you for watching my show. Could you guess what the animal is? I'll give you a little hint. It has a shell, and their mouth is underneath it. And you guess if it has ears. And it is a turtle.